Hello and welcome to this video on how to factor a two-term polynomial when you're given a difference of squares. Now before we get started, we need to talk about what a squared number is. A squared number is any number that has a perfect square root. So for example, 9 is a squared number because the square root of 9 is 3. What are some other squared numbers? For example, 16 is a squared number, 25 is a squared number, 81, and even 100 is a squared number because it's 10 times 10. We can do this with variables as well. X squared is a squared number because it's x times x. And even x to the fourth is a squared number because it's x squared times x squared. Or 9x squared. That one works as well because both of the numbers can be squared. If you are given two squared numbers and they are being subtracted, this is very important, it's got to be perfect squares and subtraction, then therefore the polynomial can be factored. Let's take a look. For example, if I had x squared minus 81, this is a perfect squared number? Yes, check. This is a perfect squared number? Yes, check. And it's subtraction. Because it's subtraction and both numbers are perfect squares, then this can be factored into two sets of parentheses. To do this, we're going to square root each of the values. The square root of x squared is x, so that goes into both sets of parentheses. And then we square root the second number. The square root of 81 is 9, so that goes into the second slot of each parenthesis. And then we write 1 with a plus and 1 with a minus. This would be our answer for factoring a perfect square. Again, three-step process. Step number 1, make sure they're perfect squares and that you're subtracting them. If they're not, then they can't be factored. Step number 2, square root both the values. You'll then write those values in to the appropriate parenthesis, the first number into the first slot of each parenthesis, and the last number square rooted into the last slot of the two parentheses, and use 1 plus and 1 minus sign. That's how we factor a two-term polynomial when it's difference of squares. Now it's your turn. Here are 4 questions we'd like you to try using these procedures, and let's see what you get. Go ahead and pause the video, and you can unpause it to check your answers. Okay, let's get started. This is a perfect square, yes. 25 is a perfect square, yes, and it's subtraction, so it does factor. Let's go ahead and break that down. The square root of x squared is x. Square root of 25 is 5. And we'll do 1 plus, 1 minus. You could always check these answers if you wanted to by multiplying it back out. You could take this times this, and this times this, and this times this, and verify that it does work, and it does. Okay, great. 9x squared, yep, that's a perfect square. 49, yep, that's a perfect square. And it's subtraction. So that's good. We can put it into two parentheses. The square root of 9x squared is 3x. The square root of 49 is 7. We'll do 1 plus, 1 minus. Excellent. Number 3, let's check that there's square roots. Ooh, the square root of 121. It does work, yep. And square root of 144, yep. So we can put it into two parentheses. The square root of 121 is 11x. That goes in the first slots. The square root of 144, that's 12y. That goes in the second slots. 1 plus, 1 minus. Question number 4 is a little bit of a bonus. Let's see if you got it. This is a perfect square, yes. 16 is a perfect square, that's good. So we can put it into two parentheses. The square root of x to the fourth is x squared. And the square root of 16 is 4. We put 1 plus, 1 minus. Now, most of you probably got there. There is one additional thing that you should be aware of when factoring polynomials. It is possible that you'll be working on a problem and you'll get it factored, and it might factor more. One of your answers might factor more. Take a look at this one here. X squared minus 4. It actually factors more because it's a perfect square. Look, x squared is a perfect square, 4 is a perfect square, and it's minus. So we can square root it to get x and x, square root to 4 to get 2 and 2, 1 plus, 1 minus. Now this one does not factor, so we just write it here as x squared plus 4. It does not factor because it's a plus sign. Remember, we said that plus signs can never factor down more. You can only factor down more if they're perfect squares and subtraction. So number 4, that was a little bit of a tricky problem, but I wanted to show you that it is possible that a problem can factor down more as you're working on it. So always be looking for that as well. Thanks for watching this video and keep working hard.